Assalamualaikum and hi. In this video, we would like to present about comparison between jet engines and aeroplane engines and the application of thermocouples in engine heat measurement. Our lecturer is Dr. Hasya and our teammates is Muhammad HAIRUL bin Ahmad Shahir, Muhammad ALIFF HAIKAL bin AMRAN, and Muhammad AZHAD NABIHAN bin Muhammad ZAHID. For the introduction, this report compares jet engines and the piston aeroplane engines. It focuses on accurate heat measurement using thermocouples. Temperature monitoring is important to prevent overheating and engine damage. Thermocouples measure EGT in jet engines and CHT in PST engines. The study covers engine types, thermocouple use, sensor placement, and aviation safety. Next, we go to literature review. For history of jet engines were developed to fly faster and higher to piston propeller aircraft. Piston engine became inefficient at high speeds. Key figure Frank White from UK pretend to project in 1930 Gloucester E28/39 in 1941. Hans von Oehing from Germany, HAIKAL He-178 first jet flight in 1939. Post-World War II, turbojet had high thrust but consumed much fuel and were noisy. Turbofan engines introduced to improve fuel efficiency and reduce noise, widely used in modern passenger aircraft. Next, we go to history of aeroplane engines. Started with simple piston engines, Wright brothers first powered flight in 1903 used a lightweight internal combustion engine with propellers. Early piston engines were busy to build, maintain, and operate compared to the turbines. Radial engines became common for commercial and military aircraft, better power and cooling. Later, in light of horizontally opposed engines used, especially in small craft, convert chemical energy from fuel, mechanical energy, rotates propeller. Main components: intake valve, exhaust valve, piston cylinder, connecting rod, crankshaft, crankcase, and spark plug. Next we go to the theory. The aeroplane engine theory. Based on Newton's third law, every action has an equal and opposite reaction. Engine push air backward, air move forwards. Piston propeller engine. Piston rotates propeller, propeller accelerates air backward and then produce thrust. For jet engines, air intake, and then go to compressor, and then go to combustion chamber, after that turbine, and lastly exhaust. For fuel burn, high pressure, high temperature gas expand, turbine powers compressor, for gas exit nozzle, forward thrust generated.
My name is Muhammad Hairul Ikwami Ahmad Shahid. My method number is S70251. So I will continue with for the meaning of input word is entitled. Right? The jet engines. The jet engine produces thrust by the compressing air, burning fuel, and expelling hot gas, with thermocouple monitoring temperature for safe operation. For aeroplanes, an aeroplane uses lift from its wings to fly and relies on engines pistons for small aircraft and turbofan. For larger airline need to generate thrust with different principles from jet engine chosen based on size, speed, range, and purpose. A thermocouple is a temperature sensor made of two different metal joints at odd junction producing a voltage via the Seebeck effect, and it used in a jet and piston engine to monitor exhaust and cylinder temperature for safe operation. Then last is heat sensor. A heat sensor in aircraft engine measures critical temperatures such as EGT, CHT, and turbine temperature to ensure safe operation, prevent overheating, and enable predictive maintenance. Next, I will continue with the comparison between jet engine and aeroplane engine. So, firstly, the comparison based on the working principle. For the jet engine, air enters the inlet, air is compressed, fuel added and burns, hot gas expand, and the last exhaust gas produces thrust. For the piston engine, air through mixture enter the cylinder, make sure it's compressed, make sure it burns, piston moves down, and crankshaft rotates properly. So, firstly, the comparison based on the working principle. For the jet engine, next is the comparison based on main component. For the inlet, jet engine allow air enter to the engine smoothly. Then compressor increase air pressure to prepare for combustion. combustion chamber. Fuel is added and burned to increase the energy of the air turbine, extract energy from the hot gas to drive the compressor and fan nozzle, accelerate the hot gas and direct them backward to produce thrust. The last fan turbofan only for the engine to draw is a large amount of air and produce additional thrust by pass flow. For the piston engine, the number one is cylinder, holds the piston and concentrated pressure. Second, the pistons move off and down inside the cylinder. Third is crankshaft power the up and down motion into the rotation. The fourth is connecting the rods connect the piston to the crankshaft. Fourth is control the mystic air fuel measure and the exhaust of gas. The spark plug ignite the air measure for combustion. The seventh full system. Fuel system is supply fuel to the engine. The eighth is exhaust system that remove the combustion gas from the engine. And last, for number nine is convert the engine rotation into thrust to move the aircraft forward. Next, for the compressor based on the thrust and power position. So the jet engine is a jet engine are usually measured based on the thrust. Thrust is the force that move the aircraft forwards. So the equation is F equals to MVC PO plus PC minus PO times with AE. The piston engines now is piston engine is aeroplane engines are usually measured based on the shaft power. Shaft power is the mechanical power produced by the engine to rotate the propeller. Then the equation is P equal to T torque time with the Next, I will continue with comparison based on speed and altitude. Jet engine. Why the jet engine perform well at high altitude? Because the compressor increases the air pressure even when A is thin at high altitude. Combustion provide a constant energy release. Continuous thrust at high exhaust velocity produce strong thrust for high speed flight. By way the piston engine, it challenges at high altitude because number one is thin air, less oxygen available for combustion. Second is power loss, so reduce engine power and efficiency. Third is turbocharger, help improve performance but still not as effective as jet engine. Next, for the compressor based on operation temperature. For the jet engine, for the jet engine, uh, the key hot area at the combustion engine, turbine blades, and exhaust nozzles. And the thermal management is a cooling system, oil cooling system, temperature sensor, and heat resistant material. But with piston engine, key hot area is at the cylinder head, exhaust valve, exhaust pipe, and oil system. And the thermal management for the cooling system, air cooling pin cylinder, temperature sensor, and the proper maintenance. So then I will continue how to comparison based on temperature measurement. For the jet engine, however, the first is thermocouple to measure the temperature at multiple points around the exhaust path. Reading are sent to the engine monitoring systems. The system are calculate the average AGT. Piston use the information to monitor the engine temperature. Then the piston engine exhaust gas temperature. The thermocouple, however, thermocouple will measure EGT and CC at multiple points. Reading are went to the engine monitor or gauge. Pilot use the data to adjust the power measure and airflow. They ensure that then lastly ensure safe and efficient engine for operation. Next, I will explain the comparison based on the fuel and efficiency. For the jet engine, efficiency feature is the high bypass ratio improve the efficiency, but piston engine efficiency feature is lightweight and simple construction. Next, I will continue a comparison based on maintenance and cost. Jet engine, maintenance requirement, complex structure with many high rotation parts. Piston engine, maintenance requirements, simple design with a few moving parts. Cost factor, high initial purchase cost for the jet engine. And the four piston engine, cost factor is more lower initial purchase cost. Purchase cost. Next, the main of comparison based on the application. For the jet engine, main application is the commercial airline, used in passenger airline for high thrust, long range, and efficient operation. Second is for the military aircraft, provide high speed, rapid acceleration, and ability to operate at high altitude. For the piston engine, main application is light aircraft used for recreation, touring, and personal flying. Then second is for the training aircraft, widely used for pilot training due to simplicity, safety, and low cost.
Assalamualaikum, my name is Muhammad AZHAD NABIHAN bin Muhammad ZAHID. Today I will be discussing about thermocouple or heat sensor in engine heat measurement. As you can see, monitoring exhaust gas temperature or EGT is absolutely essential in modern aviation for safety and preventing the turbine damage. We rely on thermocouples for this task because they are remarkably rugged self-powered, and can easily withstand extreme engine exhaust environment. Moving to the theory, they operate on the seabed effect, burgeoning two dissimilar metals to create a hot junction. A tiny voltage is generated when exposed to heat. By measuring the voltage difference between this hot junction and a core reference point, the aircraft computer can accurately measure exhaust temperature. Now, let's examine the industry standards. The Type K thermocouple, as detailed in the table, it utilizes a chromomer positive conductor as an aluminum negative conductor. This combination makes it highly resistant to corrosion and capable of measuring extreme exhaust gas up to 1200 degrees Celsius, producing a non-linear output of roughly 40 microvolt per degree. In practice, an aircraft system doesn't rely on just one sensor. Typically, 4 to 16 thermocouples are mounted in the parallel inside the exhaust stream. This parallel wiring average the individual voltage, yielding a highly stable reading. Ultimately, this continuous accurate reading allows flight crew to maintain safe operating limit and extend the engine lifespan.
In conclusion, jet engines and piston engines both provide aircraft propulsion but operate differently. Jet engines suit high speed and high altitude flight, while piston engines suit smaller aircraft. Both require reliable thermal monitoring. Thermocouple measure EGT and CHT to prevent overheating, protect components, improve performance, and support modern maintenance practices in aviation.